Hello, good morning, everyone. Welcome to Singapore AI Technology Meetup. So in this meetup, every month we are bringing AI technology updates and from startups and the technology itself. So every month we are hosting this Singapore AI Technology Meetup, where we bring a lot of new innovative technologies and updates from various organizations, startups, and like-minded people. So keep tuned to our meetup to know about these areas in the AI technology updates in the APAC region. So today we are joined two meetups together in the Hong Kong AI technology and the Singapore AI technology meetup together to present this session. So today's meetup we have over 40 registrations for this meetup session. So we are waiting for a few more participants to join in as well. So today we have Nota AI, the startup working on the AI optimization technology stack. So they will be presenting about their product and how it can be used in the various sectors and various use cases in the AI development product cycles. So if you have any questions and related to this session, you can put into the chat or you can unmute yourself and ask. So we have a Q&A session during the end of the during the last 10 minutes of the meetup session as well. And we'll be recording this meetup and we'll be sharing that as well. So let me now hand it over to Eric to get started.
Okay.
Eric, yeah, you can start. You can share the screen now.
Okay. Okay, wait a minute. Okay, thank you for introducing me. I'm Eric Hong, and research engineer in Nota AI. Can you see the screen?
Yes, sir, we can see this.
Okay. So let's. Okay, before the tutorial, I shared the link in the chat. So you can find out. The tutorial video link and QA question answer link. If you have any question during this tutorial, you can visit the QA link, which I just shared in the chat room. So you leave it here, leave it question, and I'm going to answer as much as possible. And at the same time, if you are really interested in the Competent Toolkit and Model Search, which are our services, you can visit this site immediately and try it. Of course, I'm going to explain about how to use these tools, but but now I just give you the links now. Okay, let me begin. Our Nota AI introduces automatic AI optimization, and this is for introducing concept and tutorial for AI model optimization. These are table of contents. Let me introduce Nota first. And this is an example of Nota's core technology and its application to real industries. And next, I'll explain the significance of AI model optimization. And after that, I'm going to explain the Nota's core technology in a little more detail. And finally, let's take a look at the Nota suite of services. MPTK is our representative service. So this is an introduction to Nota AI. Nota was founded in 2015 as a student venture at KAIST in Korea. It's been 7 years this year, and Nota is collaborating with several partners and clients as follows. And among them, we are in a premier partnership with NVIDIA. Premier partnership are a tier that only has the top 1% of our NVIDIA partners. And it can be seen that they have a strong will for strategic partners with us. And Nota's investors include LG CNS and Samsung Venture Investment in particular. It's known that Nota is the only case in which two competing companies, LG and Samsung, have invested in one company. And currently, the total amount of raised fund in Series B is total 22.5 million dollars. Nota AI's investors include Nota has offices in Berlin and Dijon and Seoul in California. Our sales are tailored to the circumstances of each country around the world, and most of our employees work remotely. Our Nota's core tech competency can be roughly divided into the following two categories. These two categories. First, our core technology, AI model optimization, which is also called Nespresso. The technology helps reduce the main power cost of creating lightweight AI models. The lightweight AI model is built to run on small hardware boards called edge devices. Second, we have many examples of applying AI models to real industries, intelligent transportation system, and access control system, and driver monitoring system. And Team Nota is a startup which currently has 74, around 80 members. Among them, R&D members count for more than 70%. This consists of researchers in machine learning, embedded systems, and computer vision. Let me explain automatic AI optimization now. In order to create an AI model, many challenges must be overcome. It's a pipeline process. Building an AI model is actually a pipeline process, and each steps cannot be skipped easily. In the research stage, the focus is training and evaluating AI models, which is a part here. But for the service in real industry, we have to cover all the full pipelines, and it's very complex and challenging. And Nespresso covers the entire pipeline of a model production process from raw data set to deployment. And Nespresso is a suite. Actually, it's an Nespresso. It's a suite of services containing auto-labeler, model search, compression toolkit, model package. These four are actually an individual services which can be provided individually, and they can be connected and they can be connected and serviced in the pipeline in a row. Now, Nespresso is a platform that finds the optimal hardware-aware AI model. It solves the following four pain points: cost of high-performance servers, low latency of AI models, and it's free from network connectivity issues and free from data privacy. When the user uploads the AI model, the data set, and performance they want, and write down the performance they want, and the target hardware spec they want, Nespresso runs the pipeline with model search, compression toolkit, and model packaging to create an optimized AI model. At this time, users can reduce the cost of manpower and server usage to create AI models. At the same time, rather than just using other general models, you get a better model, which suit for your situation. This is the figure. This is a drawing that summarizes the overall configuration of Nespresso. First, you give a data set, upload the data set, and write down the spec of target hardware and write down the requirement you want for the target performance. Then there are three tasks. Classification, object detection are available currently, and segmentation will be serviced later. And if you put these three set of requirements, the Nespresso uses modal search in these two, modal search and compression toolkit, and it produces optimized AI model. This optimized means optimized for edge device hardware. And the Nespresso includes runtime engine, which is tensor like something like TensorRT and JFlight often we know. And each runtime engine is all available now. You can try it. So deep learning vision tasks are broadly classifies images using labels such as cats and dogs. And localization uses bounding boxes. And the task of finding multiple B boxes with an image is called object detection. And in a completely different form, the task of classifying the shape of specific object in an image is called segmentation. And we create Express for use for edge devices, but it can be also used for the cloud service. It doesn't necessarily have to be used on edge devices. The model created with Nespresso also works effectively in the cloud environment. For example, the table on the left here compares a model made with Nespresso and a model without on the same P100 instance on the cloud. The cost is the same for the cloud service, and the performance is similar. And however, you can see the number of channels here are about 5%, five times better than the previous one. And the table on the right is different cloud instances. If you use different cloud instances, it can be seen that when using T4 instance, which is 85% cheaper than the VBAC instance, V100 instance, it achieves the same accuracy, like the similar accuracy with the much lower cost and much higher bandwidth, much wider bandwidth. So Nota has two business with Nespresso. One is to provide Nespresso. This is an automated AI ML platform as a service to help customers create their own AI model without AI engineer. And another is that our Nota AI engineers directly support consulting service for the different situation for each customers. For the domain example, I'm going to introduce the Nota access control system. The access control system is used for protecting personal information at home, office, and industry, or healthcare use. And these all cases are currently undergoing. These are all the facts, and we actually have real industry case. Let's watch the video here. Now I'm going to introduce the driver monitoring system, which is another industry example of Nespresso. This DMS, driver monitoring system, is for a driver in the car. Actually, it's more for a driver in the car, which car is the autonomous vehicle. When this driver drives a car without attention, without enough attention, then you can see the eye closes. If he is sleepy or drowsy, the eye will closes, and you can the camera here detects the yawning or eye closing or head pose and make a decision if the driver is sleepy or drowsy or not. And this is the edge case of optimized AI. The gaze status and eye status and head pose. Okay. Yeah, as you see here, when the driver drives the autonomous vehicle, the driver can easily lose their attention. And in the Europe or Berlin, which are branches there are a strict regulation that if a autonomous vehicle is produced, each autonomous vehicle should have this kind of inspecting the device which can inspect the status of the driver is required by the regulation of the law. So you can see this example. This is very recent. It's in April. And this Blackview driver monitoring system contains our Nota AI core technology.
Driving is a part of your everyday life. In a world where it's easy to lose focus or feel exhausted, mistakes can be costly. Introducing the Blackview DMS lineup, featuring the new DMC200 driver monitoring camera. The DMC200 is a revolutionary AI-powered camera that detects when you lose focus of the road, such as times of drowsiness or distraction, and sends a warning in real time, keeping you safe. The DMC200 also acts as a high-quality infrared camera capable of capturing clear footage of your vehicle's interior for safekeeping. The DMC200 is available with a range of cloud-compatible 4K and Full HD front cameras. When combined with Blackview Cloud, the DMC200 generates driving reports that can help identify potential safety issues and promote safe driving habits. The DMC200 driver monitoring camera, making sure you get to your destination safely. Find yours at
Okay. This is a real case, and the Edge AI. You can see that this is a trivial example of usage in Edge AI, because in the car, I mean that there are normal AI and there are Edge AI, and they have different usage. And Edge AI is typically used in barren or barren site or barren situation. For normal AI system, they can have almost infinite amount of electricity, and they are connected in LAN cable, and they can transfer data at any time they want. But in Edge AI, For example, in the car, there's no LAN cable and there's no electric power, infinite electric power. They just supply the power by the battery in the car. So the charge is very limited. In this kind of situation, the HAI can perform or under the sea or on the air or in the car, such that a barren or harsh environment for the devices. So HAI can run without the LAN cable or power cable. And it means it's the meaning of the on-device AI. And I'm going to explain NOTA AI, Intelligent Transportation System. Okay, there are three different types of intelligent transportation system. A smart camera. It's a real-time on-device traffic monitoring system. It counts the number of bus, car, and trucks. And if there are many cars on the road, it gives a longer traffic signal. And if there are less car and trucks, and then this traffic signal is the duration of the traffic signal is shortened. And the second type of task is smart traffic signal. This is smart traffic signal control, actually. This is to counting the cars and buses. This is for monitoring. This is for signal control. This is for protecting the pedestrians on the road. And we have many use cases. This smart camera system was applied in Yangsan and Pyeongtaek and San Diego. And notice a success story on GTC 21 feature. NVIDIA regularly opens an event which his name is GTC 2001, 2022. And we were introduced in NVIDIA GTC 2021 is a very successful story. It features an on-device ITS solution with using the NVIDIA Jetson series, actually Jetson Xavier device. It's real-time traffic signal control and intelligent video analytics application. You can see the demo video. Okay, time is 11:25. Now I'm going to introduce the AI optimization, what and why. This is a basic figure that explains the relationship between the three terms. Artificial deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. And the history of artificial intelligence is started from early 1950s. And these figure explains the difference between deep learning and machine learning. The main difference between the deep learning and machine learning is that the feature extraction stage is done by the human worker. In deep learning, automatically extracts the features. This is the main difference between the key terms machine learning and deep learning. And there's a difference between human vision and computer vision. And actually, the computer vision is very similar to the human vision and eyesight and brains. Okay, for example, a civil engineer use case, deep learning model trains input images. Actually, I'm going to explain with the vision, only vision case, not NLP or speech. Train an image and classifies it. Actually, it's a decision machine. A neural network is actually a decision machine which decide cat or dog or damaged or not damaged. If the model is trained with the data set, and in the deployment stage, they use the neural net uses inference with the images they have never seen before. For example, like this, if there's a crack in this part here, deep learning model actually it's a decision machine. So it decides which part is correct or which part is not. And the problem of current AI model, which is a decision machine, the problem of current decision machine, which is also called AI model, here is that model size is getting bigger and bigger. It's April 2020. It's around 2 years ago. They have GPT-3 model. OpenAI introduced a GPT-3 model, which has 175 billion parameters, which is very huge. And if they want to make the model accurate and inaccurate, the cost for the accuracy to attain an accuracy from 99% to 99.9%, which is just 0.9 percent point, they have to pay tremendous amount of dollars, right? And the training GPT-3 model costs over $4.5 million using a single training using Tesla V100 cloud instance. This direction is one major research area, major research purpose. It's okay, but not everybody can perform like this. Only with the capital support, huge amount of capital support is required to conduct this kind of research. So these are these figures shows the comparison between each models. So this diameter represents the size of the model, which is 19, 16, 13, 11, and number of these x-axis represent gigaflops, floating point operation. The less, the better. And this y-axis represent the top one accuracy, which is higher, the better. You can see that with the same accuracy, it's more recommended that using the lower flops model here. With the same accuracy, it would be better for us to use this one rather than this one. So deep neural net, and we provide lightweight deep neural network so that we can, with the same figure, with the same graph, it means that we can endure these 0.9 percent point accuracy drop. With the little small accuracy drop, we can attain higher cost benefit. So there are different terms: tiny ML, on-device AI, edge AI, embedded AI, edge intelligence. These terms is for real-time customer engagement and reliable reliable service and sensor data analysis with a highly responsive and security and privacy, because they don't have LAN cable connected. All the data set, all the data they collect is consumed within the device. So it is called on device. So there's no security and privacy issue, and for greater customer experience and scalability cost. In this kind of Vector environment, this is another example of Vector environment. There's no LAN cable, there's no power cable. The device on the air should decide this part is correct or not with the lower electricity support and low data transfer. Every data set, every data they this device collect should be consumed within the device. So the model, AI model in the device of this drone should be optimized very compact. It should be very compactly optimized for the device, hardware device here. So AI optimization, Nota AI is deep learning and GPU. We use GPU accelerator and we conduct image classification, object detection tasks, and we sell our products in AI marketplace. And we provide AI service for cloud, and not only cloud, but the edge device, edge AI. The Nespresso is actually not an individual services, but totally a pipeline component like this. We deliver by optimizing models from auto labeler through MLS pipeline to test model package to deploy edge or cloud services. For that purpose, we can attain the small or optimized model with the compression toolkit and model search. These two, compression toolkit and model search, works differently, but they have actually the same objective, to attain an optimized AI model. And roughly speaking, this compression toolkit compresses a large model and into smaller one. And the model search is opposite. It searches from the very scratch to find a small optimized AI model. And it means that it's bottom-up approach, it's top-down approach, and the objective of these two, model search and compression toolkit, are the same. So Nespresso is an automated AI optimization platform, and it's a suite of several services. It's not a single service. And each individual service is model search and compression toolkit and model package. Actually, we have auto labeler, and it's still on the development process, and it's not yet launched. And this auto labeler is relatively less important than the others, because there are many open source auto labelers and very many cases on the web. So, but these model search and compression toolkit are very unique for our company. So this is important, but less important, and these are much more important. Auto labeler helps the users to label not from the scratch, but from the already generated B boxes. The labeler can only edit the B boxes which are already drawn by the YOLO models. Let's Nespresso model search. The input of Nespresso model search input is given data set and hardware device, specs, target, and target MAP, mean average precision, and latency. These are requirements, and this is given data set and hardware. With these input, the Nespresso model search maximizes MAP and minimizes latency for an object detection case. The metric is mean average precision, so it maximizes MAP. And output is optimized AI model. And there are, the user can choose in their taste. If they want higher accuracy, it produces, if you put here, I want higher accuracy, then the Nespresso model search produces much higher performance. It relatively slower inference speed. And if the user wants much more faster inference speed, then it finds the model. The priority is in latency, faster, but the accuracy has a little dropped. And this is a result table, NP performance here. performance, the priority is in performance, but priority is in the latency case like this. If they have lower latency, which is lower the better, they have lower MAP, the higher the better. So there is this kind of trade-off. For these several candidate models, the model search searches and print out a final optimized model among these all candidates. And the model search finds the optimal model which fits, which is suit for the user's requirement. And model search is actually the technology behind the model search is neural architecture search. Actually, it's multi-objective neural architecture search. It's actually closely related to network compression. Both NOS and network compression they both are aiming finding well-performing but efficient architecture. I said that they have two different types, top-down. This is bottom-up. This is top-down approach. They have different approaches, but they have the same objective. For the trivial case, this is a skip connection. The diagram is about the skip connection in the residual block. This kind of architecture is searched by the human researcher. It's a type of architecture search, but it's well drawn because we human likes regular patterns. But with the iterative process like this, neural architecture search, the final model is like this, automatically finds these structures, very complex structures, which are found by the machine. And our Nespresso model search, our characteristic is hardware-aware neural architecture search. It means that the performance of latency and MAP to find the model, the Nespresso model search considers the performance in the edge devices, not in the server. If it finds the candidate model, it sends the model to the edge device and produces its performance and latency and come back and compare the candidate with another candidates. And if it doesn't satisfy the requirement, it picks another one and send it to the real device. The point is that it's not a simulator. The model performance in latency and MAP is not based on the simulator, but it's on their own. Every performance is measured on the real devices. So we support computer vision, two types of computer vision tasks: object detection and classification. And we support the major three types of runtime engine, TensorRT, TensorFlow Lite, and OpenVINO. And these are the supported hardware. And the performance means that this multi-real-time people detection on just now. We have three types of models. We have 1, 2, 3 different models in one device. The FPS frame per second is over 10, right? 13 actually, 13. And these three different models are run in just one single device. Okay. These three different models run at the same time, simultaneously, in a single device. And we see that the FPS is over 10. It means you can use in the real case. This time we have, it's 11:14. So let's try the Nespresso compression toolkit. The model search actually. You visit here You can visit this website here, modelsearch.nespresso.ai. Okay, let's model search. Actually, when you visit Nota.ai, click the Nespresso and try Nespresso. Okay, I'm going to deal with the questions later. Okay. There are model search. It's for free and it's open. Actually, the beta service of Nespresso is opened publicly opened in April 20. It's 29, so it's already about a week. You press this button and access. Since the model search is it uses GPU resource, so so the number of people can use Nespresso model search is restricted. So you give your information to us, you register, and we are going to assign you a GPU resource to try the Nespresso model search. So this tutorial is not valid yet, but you can try it home at any time. We are going to use, in this tutorial, we are going to use the Nespresso compression toolkit. Compression toolkit. For example, you visit, okay. You visit compression, sorry. First, visit our website, Nota.ai, press Nespresso, and try Nespresso. And you can see these three links. And model search is available, and you can use it in the queue. You can use it, but you need to register and attain the GPU resource. And this compression toolkit does not use the GPU resource, so you can anytime use immediately. And this model packaging service will be available in July 2022. So in this tutorial, we are going to use this compression toolkit and press get started for free, this button, and sign up. It's free. It's sign up, and when we have an account, press login and look around these things, and okay, press this model 2, and we prepared a free, actually it's a free simple model. I'm going to use Keras 100 pre-trained model and VGG 19.h5, which is a Keras model. So in this tutorial, I'm going to show how to use the compression toolkit. You upload an AI model, Keras format or PyTorch format, anything is okay. And upload VGG 19. Select upload model like this. It's very simple. Give them name and upload the model. Wait for like under less than 30 seconds. And Shangwon gave me a question. use cases. Can you touch on how they work? For example, DMS probably auto-label and classifies the driver's face, but what goes under the hood? What goes under the hood? In the driver monitoring system, the AI model is already pre-trained, and there's no training during the driving. And even in the case, we trained the AI model with many suit of data set, so it can cover any type of faces, like black and white, Asian. Not that it does not matter. If it's a face, it's okay. And in the AI model, in the black box, the model is already trained for human face, and there's no training phase. It does not collect data set. It does not like train a model in the real case. During the driving, the model just inference you're sleeping or not. It performs just an inference, not the training. Is that your intention? Is it correct answer, right? I don't get it. If you have more questions, please let me know. The model is unloaded and press compress. I said that this espresso compression toolkit is top-down approach. If you have already a large model, you can get a trained model. You can get a compressed model. There are several types of compression method. I'm going to pick the Tucker decomposition. Actually, mainly there are two types of compression method, and structured pruning and filter decomposition. These two types of compression method does not need the training phase. So it's very fast and does not make much time. And it shows that this milliseconds means that inference speed. I unloaded this model on the web or server, and the server automatically gives this model into the Raspberry Pi version 4, and it measures the inference speed. Okay, let's pick this one, this feature layer. By the way, the compression toolkit covers every type of CNN-based model. Any type of CNN-based model is available on our service. Like you give them a in rank and out rank and compress. What I'm doing is that I upload a model and try to compress this one single layer with the method of Tucker decomposition, which require input as in rank and out rank. If you want to know much detail about the Tucker decomposition, you can refer to the document or user's document here. It said process can be up to 5 minutes. Okay, and then you can see the compressed model is automatically downloaded. And this means the depth matrix flops, floating point operation per second, and model size, and number of parameters. It's very small. You can see that it's almost 1, right? But it's a little bit less because I just compressed this just to a single layer. If I compress the whole layer, the compression ratio will be increased. So to see the effect of model compression, you visit the site Netron like this. Remember this one, Netron. Use and press open model. And then on the left side, I'm going to upload the model, original model. And on the right side, I'm going to upload compressed model. You can see the difference. This is a VGG19 structure, model structure, and the only difference between these two are like this and this. The one single layer, 3 by 3 by 64 by 64 shape, is decomposed into these 3 layers. And the number of parameters here, 1 times 1 times 64 times 32 plus 3 by 3 by 32 by 20 plus 1 by 1 by 20 by 64. How much is it? I don't know, I calculated earlier. I calculated the result here. It's like this, 3 by 3, 3 by 3 by 64 by 64. I mean, the number of parameters is reduced 4 times, right? This is for since this is an example, I compressed just a single layer. But if you compressed every convolution layer in the neural network, then the compression ratio, the four times this compression ratio, you applied the whole neural architecture. So this is an effect of network compression. And one point is that even with the smaller number of parameters, the accuracy, the finer performance of accuracy is very similar to the previous one. And the latency, the model inference speed, gets faster. That's the effect of model compression. And compression toolkit you can use anytime. It's publicly open and free for all. Okay, and the final one is model package. This one, model package. The network, it's 11:50. So we have just 7 minutes left. Dear host, can you stop here and collect the question answer? If they have many questions, I'm going to answer. But if don't have, I'm going to explain a little bit more. How is it? Okay, there's one question. Can we use this technology with reinforcement learning? Actually, in this current stage, we only support the task of computer vision with CNN-based architecture. It means that if the reinforcement learning model has some kind of CNN architecture inside of it, somehow, then you can use it. Then we can use it, but we don't primarily support, we don't primarily aim to solve reinforcement learning tasks currently. We should focus on computer vision with CNN-based models because they are, our companies should earn money. So we have to aim, there are priorities. So in the future, maybe we can cover every kind of tasks, but at current stage, we are startups, so we are current stage. We have to aim for the market aim. We have to consider the market size, and I guess that reinforcement learning is not of course it's a mainstream of research, but it's a little bit early stage of industrial science, I guess. So. Okay, let me check if there are more comments or what is the format for deploying onto the edge device? Actually, it's a TF-Lite. Mainly, it's a TF-Lite format in the Nespresso compression toolkit. But if you want, you can use TensorFlow. You can use TensorRT or OpenMINIMum format. But mainly, we support the TF-Lite format. Okay, we have 4 minutes left. Please give me a question. I'm going to wait for 30 seconds. And if there's no more question, I'm going to wrap up or summarize the presentation today. 1, 2, 3. No question? Okay, then let me summarize. I'm going to summarize today's presentation. And I stopped here explaining the model package service. Actually, the AutoML, the support Nespresso is actually a full pipeline AutoML service, which include the hardware edge devices specs. So that's the characteristic of edge device. When you use edge device, it's a low cost and no privacy concern and standalone device. This is a Raspberry Pi, just Nano or OpenVINO, like that. That kind of edge devices have perception, very high perception. It's very low perception response time because it's installed on the driving car. They don't take this route. So it's very fast. So this is the main page of introducing the model package. The model produces by the Nespresso model search or compression toolkit automatically send the candidate model into different types of devices parallel at the same time, and they calculate the inference speed and accuracy, inference speed and MAP, and the return and the result returned to Nespresso, and it compare the result of each models, and if it's okay, it gives return. If it's not, it picks another candidate and send them again and get the collect. So it's a hardware-aware architecture search. So this is our patent, and this is our strong point. Okay, during this tutorial, I explained about Nota AI and a little bit introduction to automatic AI optimization. And I introduced 3 different types of domain or industrial use case: access control, driver monitoring, and the intelligent transportation system. And I explained AI optimization, a theoretical conceptual ideas of how and why and what AI optimization is. And I explained a little bit about auto labeler and model search. And I showed this model search compression toolkit, which abbreviation is NPTK. I showed a little demo here, and you can use this right away, immediately. And this model search, you can use it, but you need to register. Before you use it, you need to register. And you have to get an access token. And this model package will be published, will be launched in July 2022, this year. And these 4 sub-services are work individually, but at the same time, we can use it through the pipeline. Okay, it's time's up to 12 o'clock. Okay, okay. What is the format? Yeah, thanks very much for this session. To leave this session. Okay. Thank you. So sure. Okay. Thank you a lot. Okay, dear host, please wrap up this meeting.
Yeah, thank you, Eric, for the session. It was really informative. Let me share my screen. So hope everyone got a lot of good understanding about Nota AI and Nespresso platform. our meetup, Singapore AI Technology Meetup, we are planning to have more sessions like that in coming months. So every month we are planning to have this kind of sessions, both online and offline methods. So this is a joint meetup from both Singapore AI and Hong Kong AI Meetup Technology group. So keep engaged to our meetup group as well, where we share a lot of updates and technology updates and a lot of new session areas. And we are planning to have both online and offline and online methods in coming meetup. And I would like to thank again Nota team and Eric as our resource person for today. And we will share this meetup recording as well, so everyone can take a look at it afterward. And you can also go through the tutorial to how to use Nota AI and how to optimize the model. Also, you can fill the survey here. That's put by Eric. You can fill the survey if you have any feedback about the today's session. And looking forward to seeing you again in next month. Keep engaged to our meetup group. Thank you all for joining.
Yeah, thank you.